Okay, so you want a piece of the AI money machine. Simple enough, right? Build a model, sell access to it, watch the subscriptions roll in. Except here's the strange part. The AI industry is on track to represent something like a $2.7 trillion market by the early 2030s. And yet, almost every major player building the actual technology is losing money doing it. OpenAI, the company that put this entire industry on the map, was reportedly burning through billions of dollars a year, even as its revenue exploded. Anthropic, Google, Meta, all pouring tens of billions into chips and data centers, before they've even proven the economics actually close. So by the end of this video, you're going to understand exactly where that $2.7 trillion is really coming from. Why building AI might be the most expensive bet in corporate history. Why the smartest people in the room keep spending like the bill doesn't matter. And why some of these companies could still go bust, even if AI changes the entire world. Because here's the thing, being right about the future and making money from it are two completely different games. Let's start with the money machine itself. Because AI isn't one business, it's stacked like a layer cake, and each layer has wildly different economics. At the bottom, you've got the chip makers, Nvidia being the obvious one. Nvidia's data center revenue alone crossed something like $100 billion in a single year, and their gross margins on those AI chips reportedly sit north of 70%. Think about that. 70 cents of every dollar is pure profit, before you even count overhead. That's not a tech company margin, that's a drug cartel margin. Above the chip makers, you've got the cloud providers, Amazon, Microsoft, Google. They buy those chips by the hundreds of thousands and rent out the compute. And above that, you've got the model builders, the OpenAIs and Anthropics of the world, who rent that compute to actually train and run the models. And then finally, at the very top, you've got the apps, the consumer products layered on top of all of it, from chatbots to coding assistants to image generators. Here's the metaphor that makes this click. Imagine the AI boom as a gold rush. Except this time, picture that Nvidia isn't panning for gold. Nvidia is selling the shovels, the picks, and the jeans at a 70% markup to everyone else who's digging. That's why, even in years when the model companies are reportedly losing money hand over fist, Nvidia keeps posting numbers that look like a money printer got loose in Santa Clara. The people selling the infrastructure are guaranteed a profit, almost no matter who wins the AI race. The people actually building the intelligence are making an enormous, unproven bet. So let's talk about what it actually costs to build one of these frontier models. Because the numbers get genuinely absurd. Training a top-tier large language model reportedly costs somewhere in the range of $100 million. Just in compute, for a single training run. And some estimates for the next generation of models push toward the billion-dollar mark. Once you add in the data, the researchers, and the failed experiments that never make it to release. And that's before the model even answers a single customer question. Then there's inference. That's the industry term for actually running the model every time you type a prompt. And inference costs money, every single time, at scale, forever. It's less like building a factory once, and more like running a factory that never stops, 24 hours a day, for every person on the planet who wants to use it at the same time. Now here's where it gets interesting, because this is where the types of companies split into completely different businesses. Kind of like how a small regional casino and a Las Vegas mega resort technically do the same thing, but operate nothing alike. At the small end, you've got startups fine-tuning existing models. Think a company that takes an open source model and specializes it for, say, legal document review. Their upfront cost might be a few $100,000 in compute and engineering. Then you've got the mid-tier players, companies raising anywhere from $50 to $500 million to build genuinely competitive products on top of rented infrastructure. And then, at the very top, you've got the frontier labs, the ones actually training foundation models from scratch. These companies are now raising and spending on a scale that used to be reserved for building actual physical infrastructure, like national highway systems or oil pipelines. We're talking data center build-outs, with commitments reportedly worth hundreds of billions of dollars over the coming years from a handful of companies alone. So how does the money actually flow back in? Well, there are basically 4 rivers feeding this ocean. The first is subscriptions. Your $20 a month ChatGPT or Claude subscription, which sounds small, until you realize these products have reportedly reached hundreds of millions of weekly users. Even a small slice of that paying a subscription adds up to billions in recurring revenue. The second river is API access. That's businesses paying to plug AI directly into their own products. Priced per token, per request. Essentially, a toll booth on every single use. The third is enterprise deals. Massive, custom contracts with corporations who want AI baked into their internal tools, often worth tens or hundreds of millions of dollars per deal. And the fourth, still mostly theoretical, but enormous if it works, is what people call agentic AI. Systems that don't just answer questions, but actually complete tasks and transactions on your behalf, potentially taking a cut of the value they create rather than just charging a subscription fee. Here's where the retention and engagement game comes in. And honestly, it's more like a casino's psychology than people realize. The companies that win aren't necessarily the ones with the smartest model. They're the ones that make switching away feel expensive and annoying. That's why you're seeing this race toward memory features, custom integrations, and building AI directly into tools you already use every day, like your email or your spreadsheet. Once an AI assistant knows your writing style, your company's internal documents, and your past conversations, leaving for a competitor doesn't feel like switching apps. It feels like starting your entire relationship with a colleague over from scratch. That's the moat, not the technology, the habit. Now, here's the part that should genuinely worry you if you're thinking about jumping into this space, because the math on paper looks incredible, and yet plenty of companies are still going to lose everything. Just like a casino has a mathematically guaranteed edge on every single bet and can still go bankrupt from bad management, AI companies have a real, provable product that people clearly want, and many of them are still bleeding cash at a terrifying rate. Here's why. The cost of compute to train the next generation of models keeps climbing, faster than most companies can grow revenue to match it. It's a treadmill that speeds up every 6 months. Reports have suggested some leading labs were spending multiple dollars in compute costs for every dollar of revenue coming in the door, essentially selling dollar bills for 80 cents and hoping the economics flip once the technology matures. That's the bet, that the cost curve bends down, chips get cheaper, models get more efficient, before the cash runs out. And that leads to the common reasons this whole thing can blow up for a company, even one building genuinely great technology. Reason 1, the model becomes a commodity. If every company's chatbot becomes roughly as good as every other company's chatbot, price competition crushes margins, the same way airlines compete themselves into razor-thin profits, despite flying planes full of paying customers. Reason 2, the compute bill outpaces customer growth, and a company simply runs out of runway before its unit economics ever turn positive. Reason 3, and this one's underrated, regulatory risk. A handful of governments deciding how these models can be trained, what data they can use, or how they can be deployed, potentially reshaping the entire cost structure overnight. And reason 4, customer trust. A single high-profile failure, a hallucinated legal brief, a leaked conversation, can tank the retention numbers a company spent billions building. So, what does actual profitability look like in this industry? Here's the scenario that plays out. If this goes right, a model company reaches a point where inference costs drop dramatically because of more efficient chips and smarter engineering, while at the same time, enterprise contracts and agentic products start generating revenue that isn't just tied to a monthly subscription cap. At that point, the same infrastructure that trained the model for $100 million can serve 1 billion queries a month at a fraction of a cent each. And suddenly, you've got a business with software-like margins, running on top of what used to be a manufacturing-style cost structure. That's the dream scenario, and honestly, it's not far-fetched. It's roughly the same playbook that turned cloud computing from a money-losing bet into one of the most profitable businesses on Earth over the last 15 years. But here's the sobering scenario too. Some of these companies are effectively racing each other off a cliff, spending tens of billions on infrastructure, based on a bet that demand will eventually catch up to capacity. The same way overbuilt fiber optic cable companies went bankrupt in the early 2000s, only for their infrastructure to get bought for pennies on the dollar and quietly power the internet boom that came right after. Some of today's AI infrastructure spenders might be building the foundation of trillion-dollar companies. Others might be building the fiber optic cables of this generation, technically correct about the future, financially wrong about the timing. And that, honestly, is the real story hiding underneath the $2.7 trillion headline number. It's not really a story about whether AI works. It clearly works. It's a story about who can survive the bill long enough to find out whether they're the casino or the gambler.